why you should be building them, how you can build them, and some of the issues we've found when building them. But mostly the thing that I want you to get out of this talk is just feel inspired about real time and how it is actually like a really important next phase of the web in general. So first, some context. I work at Inlight Media. We're a digital agency based out of the heart of Collingwood, Melbourne. I work in the worldwide warehouse. We're up here, so we haven't filled that whole space yet. But every day we're building software. We're building web apps and we're building iPhone apps. It's actually really interesting building those two in the same at the same time. We all try and share those skills. You start to see the communication between the two and ways of improving that. So something that we came across is sending live content or adding real-time nature to our apps. So an app that we worked on started last year. The Clemenger crew employee here, we worked with them. Was an app called DraftPick. So it's an iPhone app that requires real-time scores to come through when you play this game while the football's on, and so when scores happen on the TV, you want these scores to update. When the server detects something, like your score down here, like based on your gameplay, will update, and there's interactions like that. So we wanted that to happen in real time, and we started to look at solutions for that. So there's the real-time scores and user activity. So traditional ways of pushing data, you've got things such as HTTP polling. This is the de facto way that basically real-time works. Real-time is implemented by a lot of people. And so basically, one of the problems with HTTP polling is you asking the server, is there new content? Is there new content? And you can set this time limit to like as much, as low as you want. You can do every second you want, hey, is there new something? And the server will reply, no, there's not. No, there's not. Yes, there is. So it's quite slow and inefficient. Asking so many times, like you've got these redundant requests where you're getting no, there's nothing new. However, it does get you pretty far, and that's why it is kind of adopted, because it does actually bring real-time enough kind of solution. The probably more interesting one for delivering real-time in the last, I guess, few years, I don't know when webhooks actually came in. Webhooks basically allow you to provide a URL to a service, and when something new happens, they'll ping that URL with the new content. So GitHub uses this. You can put in your repo URL, and when someone commits, it will ping that URL and say someone's committed to that repo. Instagram has a real-time API, so they talk about their real-time API, and that's again webhooks. You subscribe to things, you pass the URL, and they'll tell you about it. Facebook has the same. You can get live status updates through webhooks. And HubSub is the kind of is the big kind of like implementation of this webhooks, where you've got publishers, subscribers, and a central hub. So publishers don't have to worry about managing the list of subscribers. A hub is a central service, and the publisher tells the hub, hey, I've got new content, and the hub manages all the subscribers and tells them, so publishers can get on with doing what publishers need to do. But something's not quite right about all this. And that's where sockets come in. Sockets are a newer HTML5. WebSockets is a new implementation, a new way of doing real time, and it's good. So, and that's what I'm going to talk about in this section. So all my images are a bit off, but basically this is Twitter has a real-time API, has a streaming API is what they call it, and the streaming API is a really good implementation of this sockets and this connection. So don't worry about this part for the moment, but as your server, you open up a connection with Twitter and you say, I want to subscribe to these terms, I want to subscribe to Melbjs, for instance. And whenever Melbjs gets mentioned, it will send it to you. Here's a tweet, here's a tweet, here's a tweet. And then your server can then talk with the user. But from Twitter's end, from this kind of communication, it's not going out, hey, is there more tweets about Melbjs? Is there more tweets about Melbjs? You get notified as quickly as possible, basically. So WebSockets. WebSockets are a constant connection you have between the client and the server, or between two apps. You could have a socket between those two. Push data as it happens, as I mentioned. And HTML5, as you know, you've got WebSockets built into it. It's supported by the newer browsers, so kind of fallbacks I'll talk about in a moment. But mobile is a big thing as well. Like, so you can use sockets and WebSockets in particular in your mobile applications, native mobile applications. So Socket.io is basically the go-to library for implementing WebSockets with fallbacks for older browsers. So it packages messages up into, you can basically send JSON around and it will take care of all the transport and the message packing. It has multiple fallbacks, so if you can't do WebSockets in the newer browsers, it will revert back to that polling, that on-polling mechanism. And also, eventually it gets down to Flash, but you don't want to be going there because it's not cool. And it does reconnections and all these kind of, there's all these kind of heartbeats and all these other aspects that keep your connection alive with this server. So Socket.io, I might have to at some stage move my images, but that's the Socket.io website, not that interesting, but they're good. So when we're implementing this with DraftKick, is we had our first iteration, we looked at these sockets, and we built Socket.io into that. That's when you look at the demos on Socket.io's website, basically implement a Node.js socket server, Socket.io server, and we had that built into our application very, so that then we could send these kind of push messages down to the phones. We had run into some issues though, like mobile carriers. There was they block a lot of ports, and so kind of this two-way communication, like Telstra in particular over port 80, doesn't want you to do these kind of WebSockets, and it kind of blocks them off. So we noticed that pretty early on. And scaling, so scaling kind of these sockets has also been a big thing. And a big reason why people don't use sockets is the issue with scaling, because now instead of these kind of short-lived connections where, hey, where the HTTP request ends quite quickly, you've now got to maintain these open connections, and scaling and load balances stuff is an issue with that. So in our second iteration, when we approached this year, one thing we realized was the building Socket.io into the app wasn't the best way to do it. Is you want basically your sockets to be a separate service that you can scale independently that sits next to your app. Well, in our case, this was that can support sockets connecting to it. But if you restart, if you make a new code deployment or your servers, even for a moment go down, then these sockets can still be maintained. And so I'll talk about that further in a moment. We solved kind of the issue with mobile. So basically we're piggybacking off the push notification, the Apple push notification port number, which is 5223 and 5224. It's the same one that's used by XMP chat, or like any kind of instant messenger. So basically any kind of, on iPhone in particular, any phone that can use iMessage or receive push notifications can get these socket messages, because carriers leave that open because users wouldn't be happy. And in terms of scaling, we distributed, we used a kind of a pub sub model via Redis, which I can go into further, but maybe afterwards chat to me about that. But so before I get on to introducing the next part, is this is all great and all, but like a lot of people aren't using Node.js on their server, and that kind of using Socket.io there's a large barrier to that, because you might have a Ruby server, you might have a PHP server, and doing something in Node.js just isn't an option. So I've put together, out of this kind of work we've been doing, I've put together a new library called Hatchet.io. Basically, Hatchet is a Socket.io wrapper. It's a service that you can implement. It's a simple implementation that basically you can. This is the kind of, it's a server that you can sit beside your application code. If you've got a PHP app or a Ruby app, let's say, is you can send from your web service over to a Hatchet server a message just via a HTTP request, let's say. You publish it to that. It's basically a hub, and then all your socket connections are connected to that Hatchet server, and they can get all those messages. So it supports channels and tokens. So basically, you might want to send something out on a channel, like let's say when a user signs up or a user logs in, that might be a user-based channel. Whereas there might be an admin channel where you want to do stats or analytics, and tokens for permission. I'll go into that stuff will make more sense as we continue. There's a code library for integrating with Node.js, JS, and like front-end JS and Objective-C, so you can implement this. So onto some code, which probably makes sense. So it's still bare bones, and probably these two things would want to be in one file, but basically you include Socket.io, and then you include, this is in your front-end JS, and then you include Hatchet. Then you can do something like get the Hatchet instance, which just plugs itself onto Windows. So that's probably not cool, but that's the way I've done it. So anyway, like I'm looking for contributions to this project. Then you create like a publisher. So a publisher connects on the demo channel with this token. So that token will actually be a really long token that is hopefully unguessable, but because this is the front end, that people can see that. So the publisher can establishes itself, and then it can broadcast, hey, a user signed up, and their names above. And so that will broadcast out on the user sign up to any subscribers who are listening. So a subscriber can watch for the user sign up event to happen. So a subscriber has a different token. So you can watch for the user sign up event to happen, and then alert that. So basically, let's get to a demo. If you visit that on your phone,